If you think the universe follows predictable rules, that belief ended earlier today. 6 hours ago, something happened that shouldn't exist in any textbook, simulation, or model of space physics. At exactly 8 UTC on March 2nd, the laws that govern how objects move through space didn't bend or wobble. They broke. NASA's Center for Near-Earth Object Studies issued a Level 5 alert, the highest classification available, not because an asteroid drifted off course, but because an event occurred that has a statistical probability of 0. Not unlikely, not rare, impossible. For 6 months, astronomers around the world tracked what we believed was a single object, a massive body labeled 3I Atlas, moving quietly through the outer solar system. Everything about it seemed ordinary. Its spin rate was stable. Its trajectory was predictable. Its radar profile showed one cohesive mass. Then, without warning, it did something no natural object has ever done before. At 8 UTC, the Deep Space Network station in Goldstone, California, recorded a sudden and extreme spike in radar cross-section. At first, engineers assumed an equipment error. But within seconds, it became clear this wasn't noise. It wasn't interference. The object didn't fragment the way comets do when exposed to heat or tidal stress. In a span of exactly 14 seconds, 3I Atlas separated into 50 distinct objects. That alone would be unusual, but what followed is what made physicists fall silent. When comets break apart, their fragments drift away slowly, tumbling, spreading chaotically, following entropy like everything else in nature. This was the opposite. The 50 fragments expelled at high velocity, then stopped, not gradually, instantly. They stabilized their rotation, locked their spacing, and formed a rigid geometric structure in open space. Picture that for a moment. 50 objects, each roughly the size of a city block, holding formation 240 million kilometers from Earth. Nature does not do formation flying. Rocks don't coordinate. Ice doesn't arrange itself into grids. Every instinct in astrophysics says this should not exist. I spoke with colleagues at the Harvard-Smithsonian Center for Astrophysics shortly after the data came in. No one was excited. No one was celebrating a discovery. The room was quiet. Because when trajectory models were recalculated for these fragments, every single simulation pointed to the same conclusion. They weren't moving away from us. They weren't scattering into deep space. They had changed inclination. They had altered velocity. All 50 objects were now on intersect paths with Earth's upper atmosphere. What makes this worse is that they are not targeting one location. Telemetry shows the swarm spreading out, fanning across latitudes and longitudes, aiming for different continents entirely. This isn't a collision, it's a distribution, a deployment. And to understand why every major observatory on Earth has entered emergency lockdown, we have to go back to the exact moment this separation occurred. At 14:15 UTC, NASA's Deep Space Network, specifically the DSS-43 antenna, was tracking the Doppler shift of 3I Atlas. For months, the signal was clean and singular. Then it fractured, not faded, multiplied. One radar return became 50 high-intensity echoes. Skepticism is essential in science, and the first assumption was error, a receiver glitch, corrupted software, misaligned instrumentation. But that explanation collapsed almost immediately. Goldstone confirmed the split. The Gaia spacecraft independently verified the astrometric change. The ALMA array in Chile detected matching thermal signatures, 3 independent systems, 3 methods. One conclusion: this was real. And the deeper we looked, the more reality began to unravel. When natural objects break apart, the fragments vary wildly in size. Dust, rubble, shards. But anomaly number 1 was uniformity. Radar cross-sections showed 50 objects, each with a diameter of roughly 300 meters, all within a 5% margin. Nature does not mass-produce identical fragments. That suggests intention, not erosion, not stress, design. Then came anomaly number 2, formation. 2 hours after the split, the fragments stopped drifting entirely. They stabilized, adjusted, and arranged themselves into a perfect pentagonal grid, each object spaced 4,000 kilometers apart. For debris to do that requires energy, thrust, communication, a feedback loop where every object knows where the others are. Rocks do not coordinate. Ice does not self-correct. And then, at 1730 UTC, came the data point that changed everything. The entire grid altered its velocity by 3.4 kilometers per second. No exhaust, no plumes, no visible propulsion. Yet the momentum changed instantly. That isn't orbital drift. That is a maneuver. I plotted the new trajectory myself. A single object gives you a line. This gave us a cone-wide, deliberate, intersecting Earth's rotation. The math was clear. These objects weren't just coming here. They were aiming. And that was only the beginning, because when we analyzed what these objects were made of, we discovered they weren't rock at all. Because when the spectroscopy data came back, the conversation stopped being about astronomy and became something else entirely. At 1945 UTC, combined observations from multiple observatories revealed absorption lines that did not match ice, silicates, or any known cometary material. These objects were reflecting light in a way that only refined metals do. Titanium, complex alloys, materials engineered to withstand extreme heat and stress, materials that do not form naturally in deep space, let alone in 50 identical copies. Titanium doesn't condense out of a nebula. It doesn't accumulate in cometary cores. It has to be extracted, purified, processed, smelted, and perhaps most unsettling of all, these materials were absorbing radar energy instead of reflecting it, explaining why the object had appeared so unremarkable for months. It wasn't invisible. It was stealthy. By this point, the term fragment had quietly disappeared from internal communications. Scientists began using a different word, probes, and then the probes moved again. At 21 UTC, something happened that violated one of the most fundamental assumptions of orbital mechanics. The swarm began accelerating, but not toward the Sun, not toward Earth, and not along its original trajectory. It accelerated sideways, tangentially, in a vacuum. Imagine driving straight down a highway and suddenly sliding into the next lane without turning the wheel. That's not drifting. That's controlled lateral motion. The measured acceleration was small, just 0.08 meters per second squared, but over millions of kilometers, that tiny push became decisive. It allowed the swarm to adjust its aim with precision. This was no longer passive motion. This was guidance. When trajectory models were extended forward by 6 weeks factoring in Earth's rotation, lunar gravity, and atmospheric interaction, the pattern became impossible to ignore. The impact points weren't clustered. They weren't random. Each object was adjusting for a different region of the planet. North America, Eurasia, South America, Africa, Oceania, a global distribution pattern. The statistical probability of 50 independent fragments naturally striking 50 distinct landmasses is effectively zero. This wasn't a shotgun blast, it was coverage. But here's the detail that made defense analysts hesitate. The velocity profiles didn't match kinetic weapons. The angles didn't suggest maximum impact energy. These weren't designed to obliterate cities, and that raised a far more disturbing possibility. They weren't coming to destroy. They were coming to observe. At 22:15 UTC, the Deep Space Network detected something it had never seen before. A burst of high-frequency transmission, less than 4 milliseconds long, hopping from one probe to the next in rapid succession. Not broadcast. Directed. Peer-to-peer. The entire swarm synchronized in under a second. They weren't talking to us. They were talking to each other. This wasn't noise. It wasn't a beacon. It was data. Timing data, telemetry, coordination, a distributed network operating as a single system, 50 independent nodes behaving like one machine. And then, buried inside that signal, was something no one expected. A handshake. The transmission protocols matched those used by Earth satellite constellations. Not approximately. Exactly. Encryption keys that take supercomputers weeks to brute force were decoded in milliseconds. The probes didn't just listen to our satellites. They authenticated. They logged in. Nature does not understand encryption. Nature does not speak TCP/IP. Within 2 hours of confirming this breach, global navigation systems were quietly taken offline under the cover of maintenance. It was the first full reset in their operational history. Flights were rerouted. Financial systems switched to internal timing backups. Government said nothing publicly, but internally, one conclusion was unavoidable. If these objects could control our clocks, they could control our world. And then Probe Alpha, the lead object, did something that changed the question from what are they doing to what do they want. It stopped accelerating. It rotated. And it aimed its primary sensor array not at Earth itself, but at the ring of machines surrounding it. Our satellites. But that wasn't the last transmission, because at 1:14 UTC, the signal changed again, and this time we didn't just detect structure. We detected content. And what that content revealed forced scientists to confront a possibility no emergency briefing was willing to say out loud. The signal intercepted at 1:14 UTC wasn't random chatter or exploratory probing. It was targeted, structured, purposeful. The Green Bank telescope confirmed it within minutes, and when the raw data was decoded, the room went silent. What we were hearing wasn't an alien language, not mathematics, not even an encoded message meant for us. It was a reflection, a mirror of our own systems. Probe Alpha had transmitted a packet of data that perfectly matched existing satellite communication protocols, not just GPS timing signals, but authentication layers, redundancy checks, and encryption handshakes that were never meant to leave Earth. This wasn't imitation. This was comprehension. Somewhere inside that object was a system that had already studied our infrastructure, learned it, and integrated it, which means the swarm didn't discover us when it arrived in the inner solar system. It arrived because of us. That realization reframed everything: the formation flying, the identical construction, the coordinated acceleration. These weren't improvisations. They were pre-planned responses to a known environment, to our environment, and the timing suddenly mattered more than the objects themselves. Because when analysts overlaid the swarm's arrival window with Earth's orbital position, something unsettling appeared. The probes weren't arriving at the fastest possible moment. They weren't taking the most direct path. They were synchronizing their approach with a very specific alignment, one that only occurs during a narrow orbital window every few decades. An alignment that maximized line of sight to Earth's entire satellite shell. In other words, they weren't aiming for the planet first. They were aiming for the space around it. And then came the coordinates. At 2:03 UTC, buried inside the tail end of the transmission, was a single data packet that did not match any satellite protocol. No encryption, no authentication, just raw positional data. Latitude, longitude, precision down to meters. When plotted on a map, the location wasn't a city. It wasn't a military base. It wasn't a power station or a data center. It was Antarctica. More specifically, it was a point deep beneath the ice at the geographic South Pole, a place most people have never heard of, but every high-energy astrophysicist knows by heart. A place designed not to look outward, but inward, into the universe itself. The IceCube Neutrino Observatory. That single coordinate changed the tone of every briefing that followed. Because IceCube isn't symbolic, it isn't political, it doesn't transmit signals into space. It listens. It detects particles so elusive they pass through entire planets without interacting. Neutrinos, messengers from the most violent events in the cosmos. And at the exact moment Probe Alpha transmitted those coordinates, IceCube sensors recorded something unprecedented. A spike. A neutrino flux far beyond background levels, not from the Sunday, not from a known supernova remnant, from a direction aligned precisely with the swarm's approach vector. The implication was staggering. Either the probes were reacting to something IceCube had already detected, or they were the source of it, which raises a question no one wanted to ask out loud. Were they coming to observe Earth? Or were they coming because Earth had already been observed? At 3 UTC, emergency protocols were activated across multiple agencies. Telescopes were retasked. Classified sensor arrays were brought online. IceCube shifted into continuous high-sensitivity mode. The scientific community wasn't debating anymore. Debate requires uncertainty. What remained now was preparation, because we were running out of time. The swarm was accelerating again, slowly, deliberately, and the models were converging. 36 days until atmospheric interface. 36 days until the objects became visible to the naked eye, until speculation became confirmation. And the most troubling detail of all wasn't their speed or their composition. It was their restraint. No broadcast to Earth, no demands, no threats, no greeting, just silent coordination, precise movement, and a focus on the one facility capable of seeing what most of the universe keeps hidden, as if they weren't announcing themselves, as if they were checking something, or someone. And whatever they were verifying, the data suggested they expected to find it before they arrived. The swarm's acceleration profile had changed again, but this time it wasn't uniform. 49 objects maintained formation, while Probe Alpha began a subtle divergence, less than 1/10 of a degree, but enough to matter. In spaceflight terms, that deviation was deliberate. It placed Alpha on a trajectory that optimized line of sight not just to Earth's satellite shell, but directly to the South Pole for the longest possible duration. That meant sustained observation. And that's when IceCube's data crossed a threshold no one had modeled for. Neutrinos are notoriously difficult to detect. Trillions pass through your body every second without leaving a trace. To see a spike, you need either an unimaginably energetic cosmic event or something artificial producing them in volume. IceCube was suddenly seeing directional coherence. The neutrinos weren't arriving randomly. They were collimated, focused, almost aimed, which forced a terrifying reassessment. If the swarm wasn't emitting neutrinos, then it was interacting with something that was, something already present. Deep beneath the Antarctic ice, IceCube's detectors form a three-dimensional lattice embedded over a cubic kilometer. It doesn't see images, it doesn't hear signals. It senses disturbances in spacetime caused by particles that barely exist. And according to the data streaming in now, whatever IceCube was detecting had been active for far longer than the swarm had been visible. Weeks, possibly months. That realization flipped the timeline on its head. The probes hadn't triggered the anomaly. They had responded to it. At 4:30 UTC, a classified analysis circulated among senior scientists. It proposed a scenario no one wanted attached to their name. What if Earth had already been broadcasting something without knowing it? Not radio waves, not lasers. Something subtler, something fundamental. A neutrino signature tied to industrial activity, nuclear reactions, or experimental physics we barely understood ourselves. In trying to look deeper into the universe, we may have made ourselves visible in a way we never anticipated. And now something had noticed. The swarm's behavior supported that idea. Its arrival wasn't rushed. It wasn't aggressive. It was cautious, controlled, almost diagnostic. 50 identical objects spreading out to sample the planet from multiple vectors, mapping, measuring, listening. That's not how you attack a target. That's how you study one. Meanwhile, Probe Alpha's attention remained fixed on the satellite layer. Since the GPS constellation went dark, Alpha had shifted to passive observation, tracking orbital debris, inactive platforms, even classified assets we didn't publicly acknowledge existed. Its sensor sweeps were precise enough to resolve panel articulation and thermal cycling. It wasn't just looking at our technology. It was learning how we use it. At 6 UTC, another event forced an emergency session. One of the secondary probes briefly illuminated, not optically, but in the infrared. A controlled heat bloom lasting less than 2 seconds. No exhaust, no thrust vector, just a thermal signature that shouldn't have been possible if the object was inert metal. That confirmed what many already feared. The probes weren't passive shells. They were active systems with internal power sources capable of modulating energy output on demand. And yet, despite all this capability, they still hadn't done the one thing everyone expected. They hadn't entered the atmosphere. They were pacing us, waiting, which led to the most unsettling hypothesis yet. What if atmospheric entry wasn't the goal? What if Earth itself wasn't the destination, but the environment surrounding it? The magnetosphere, the ionosphere, the artificial shell of technology we've wrapped around the planet in just over half a century. A civilization that wanted to understand us wouldn't start by landing in a city. It would start by studying how we organize our sky. As this realization spread, governments shifted their posture. Missile defense systems stood down. There was nothing to intercept anyway. You can't shoot down 50 objects moving in coordinated formation without triggering unpredictable consequences. Instead, the focus moved to containment and continuity. Backup timing systems, isolated power grids, analog redundancies, long dismissed as obsolete. Because the question had changed. It was no longer, are they hostile? It was, what happens when they decide they've learned enough? And as the swarm continued its silent approach, IceCube's neutrino flux climbed higher, almost as if something beneath the ice was answering back. Whether it knew it or not, by the start of the 5th day, the word approach no longer felt accurate. The swarm wasn't closing in so much as settling into position, like pieces on a board waiting for the next move. Orbital decay calculations showed something unexpected. Their paths were stabilizing, not descending. Whatever energy systems they were using were counteracting atmospheric drag before it even became relevant. They were choosing altitude, holding it with intent. And then IceCube reported something new. The neutrino flux didn't just increase, it changed character. The energy spectrum shifted toward a narrow band, highly specific, sharply defined. Natural cosmic sources don't do that. Supernovae produce broad signatures. Active galactic nuclei smear their output across ranges. This was precise, almost tuned, as if whatever lay beneath the ice was responding to an external stimulus. That stimulus aligned perfectly with Probe Alpha's orientation. For the first time, scientists considered a possibility that bordered on the unthinkable. IceCube might not just be a detector in this scenario, it might be part of the experiment. IceCube was designed to listen outward, to catch whispers from the deep universe. But it is, by necessity, also a massive instrumented volume of matter interacting with particles in controlled, measurable ways. If something wanted to test Earth's capacity to detect, process, and react to exotic signals, there could be no better target, which reframed the transmitted coordinates entirely. They weren't a threat marker. They were a point of contact. At 11:20 UTC, a coordinated change rippled through the swarm. One by one, the probes adjusted their spacing, compressing the grid into a tighter formation. The maneuver was slow enough to be unmistakably deliberate. No urgency, no panic. Just refinement. Simultaneously, a new signal appeared. Unlike the earlier bursts, this one wasn't narrowband. It was broadband, low power, almost gentle, spread across frequencies we use every day. Microwave, VHF, even optical flashes so faint they only registered when multiple telescopes pooled their data. It wasn't trying to overpower our systems. It was trying to be seen. And perhaps more importantly, understood. Signal analysts noticed something subtle buried in the noise. Repetition with variation, not primes this time, not clean mathematics. Instead, patterns that resembled error correction, redundancy. The hallmarks of a system designed to communicate with an unknown receiver and adapt if the message isn't getting through. That realization sent a chill through every control room. Because adaptation implies feedback. And feedback means they were watching how we responded. Every shutdown, every rerouted satellite, every emergency broadcast left a signature. Changes in electromagnetic clutter, variations in orbital behavior. Even the sudden silence of GPS would have been obvious to an external observer. We weren't just being studied. We were participating. At 14 UTC, Probe Alpha executed its most dramatic maneuver yet. Without warning, it fired a burst of energy directly downward. Not a weapon, no impact. Instead, a focused interaction with Earth's magnetosphere that caused a brief, localized auroral flare over Antarctica. Green and violet light rippled across the ice for less than 30 seconds. The message was unmistakable. We are here. We can touch your world, and we are choosing not to harm it. That moment marked a shift. Public statements stopped hedging. Governments still avoided the word contact, but scientists didn't. Internal memos now referred to the swarm as an active intelligence, unknown origin, unknown intent, but demonstrably capable of restraint. And restraint is not a trait we associate with natural phenomena. Still, the biggest question remained unanswered. Why now? Why appear in 2026, not a century earlier, not a century later? The answer began to emerge from IceCube's deeper logs. Buried in archival data were faint neutrino anomalies going back decades, too weak to flag at the time, too rare to pattern match. Until now, it appeared Earth's neutrino voice had been growing steadily since the dawn of the nuclear age, accelerating with particle accelerators, reactors, and high-energy experiments. What we thought were whispers into the void had slowly become a signal, and something, somewhere, had finally decided it was loud enough to warrant a closer look. As the swarm held position and IceCube continued to light up beneath the ice, humanity stood at an unfamiliar threshold. Not invasion, not salvation, but evaluation. The universe wasn't attacking us. It was assessing us. The realization settled in quietly, without alarms or dramatic announcements. Evaluation was the only explanation that fit every observed behavior, the restraint, the precision, the refusal to escalate even when they clearly could. By the sixth day, The swarm had become a constant presence in the sky, not looming, not hidden, simply there, like a question left deliberately unanswered. IceCube's data stream never stopped. What changed was how scientists read it. Instead of hunting for spikes, they began mapping correlations. Every maneuver by the probes was followed by a subtle response in the neutrino field. Not an echo, but a dialogue pattern. Action, reaction, pause. As if the system beneath the ice and the intelligence above the atmosphere were slowly aligning their expectations. Then came the most unsettling discovery of all. Buried deep in the broadband signal was a structure no one expected to find. Compression, not random redundancy, not noise shaping, but a clear attempt to reduce information loss across an unknown medium. This wasn't a broadcast meant to impress. It was optimized to survive misunderstanding, to be reconstructed imperfectly, yet meaningfully, by a civilization still learning how to listen. In other words, the message assumed we were limited. And it respected that. That assumption forced a hard look inward. For decades, humanity had debated how extraterrestrial intelligence might treat us, projecting hopes or fears rooted in our own history. Conquest, salvation, indifference. But this scenario fit none of them. The swarm behaved less like an empire and more like a reviewer, less like a god and more like a scientist.